and welcome to the video. In this video we are going to talk about congruency in shapes, and in particular congruency in triangles. We need to know that the word congruency in maths, the word congruent, means shapes that are exactly the same. They are the same shape and the same size. Using that bit of information, I want to start this video with a little investigation. I want you to have a look at all the triangles on the screen, and I would like you to see if you can match up any triangles that are exactly the same. I also want you to have a little think about how could we prove that the triangles were the same, that the triangles were identical. And then I also want you to have a little think about this question. Does the topic of transformations have any relevance to this investigation task? Okay, I'd like you to pause the video now, give yourself 4 or 5 minutes and see if you can match up any congruent triangles. Okay, welcome back. I'm just going to show you my solution. Here we go here. Okay, so first of all, if we look at this triangle, we have a side of 3, a side of 4, and a side of 5, which is exactly what we have here. Even though the shape, the triangle's been rotated slightly, it is still exactly the same triangle. So yeah, we can join these two triangles up and we can confidently state that they are the same. We also have these 3 triangles, which I've used the yellow highlighter to make stand out. So first of all, if we look at the top right, you can see the things that I've highlighted. We've got a side of 7, an angle of 78, and a side of 8. And if we come down here, again, the shape's been rotated, but it still remains the exact same triangle. A side of 7, an angle of 78, and a side of 8 centimeters. So because I know those 3 dimensions, these two have to be the same. But it also means that this triangle could match up to form a group of 3. Because yes, we didn't know the 78 degrees, but we do know that the 3 angles in a triangle have to add up to 180. So I could have worked out this missing angle. And again, by rotating the initial shape, I've got a side of 7, an angle of 78, and a length of 8. We're going to talk a little bit more later on in the video about why these 3 values, just identifying 3 corresponding values, would be enough to tell us that the triangles are exactly the same. Okay, so I've just presented them in a different way here. So you can see the 3 shapes that I highlighted in yellow. Again, we have them all here. 8, 78, and 7. 8, 78, and 7. And again, we didn't know this angle, but we can work it out. 8, 78, and 7. Look how when I'm dealing with the shapes, I'm trying to identify 3 corresponding bits of interest, corresponding sides or corresponding angles, 3 corresponding properties that would lead me to say they were the same. This one's a little bit easier to visualize, I think. 4, 3, and 5. 4, 3, and 5. Again, we're quite confident that this triangle is exactly the same. It's just been rotated slightly. In the initial investigation, I did ask you also to think about the topic of transformations. Transformations, of course, being reflection, rotation around a center of rotation, translation, and enlargement. So let's have a think about each one of these transformations individually. And remember, the idea of today's lesson is congruency, shapes that are exactly the same. So if I took this shape and I reflected it in this blue mirror line, it would land here, and the size of the shape would not have altered. The orientation of the shape would have changed, but the size of the shape would have remained the same. So when we're dealing with a reflection, we're also dealing with congruent shapes. And in this question, a congruent triangle. If I took this shape, same shape again, and rotated it 90 degrees or 180 degrees around this center of rotation, if I went in the clockwise direction, the size of the shape would not alter. The shape would remain the same size. Again, the orientation, the rotation of the shape would have changed. Where it is placed on the screen would have altered, but the size would have remained the same. So when we're dealing with a rotation, again, we're dealing with congruent shapes, congruent triangles. Here we have a translation. I'm going to use the vector to translate this shape 2 to the right and 1 down. So if I took this shape, moved it 2 to the right and 1 down, the size of the shape would again not have altered. I would still be dealing with a length of 7, an angle of 78, and a length of 8. So when I'm dealing with a translation, again, I'm dealing with congruent shapes, congruent triangles. If I look at an enlargement, if I took the shape that I've been dealing with and enlarged it by a scale factor 2 from this center of enlargement, I would end up with a shape up here, a much larger shape. So yes, the 78 degrees would remain as 78 degrees, but this length of 7 would have changed. It would have become 14. And this length of 8 would have changed. It would have become 16. So when we think about an enlargement, usually we are not dealing with congruent shapes, because usually in an enlargement, the shape would have increased in size or decreased in size, which means that the corresponding sides would not be the same length, so we would not be dealing with congruent shapes. The reason I use the word usually is because when we start talking about an enlargement of 1 or an enlargement of -1, then of course the properties of the shape would remain the same and we would be dealing with congruent shapes. Okay. So if I was to give you this little question here, which of the following shapes are exactly the same? So let's have a little look. So first of all, I'm going to look at this shape. It's much bigger than these other three. So I'm going to rule this shape out very early on. It's got a length of 9 and a length of 8, which are longer sides than anything that is depicted in these three triangles. Of course, the shapes might not be drawn to scale, but as soon as I check the 9 and the 8, I can see that this one is not the same size as the other three, so I'm going to exclude that. Now I'm going to have a look at these three shapes. Here I have a length of 6 and a length of 4, and in between that, enclosed by those two sides, is an angle of 42. I also have the same here, a length of 6, a length of 4, and enclosed is an angle of 42. Remember, three properties are what I'm looking for. If I go down here, yes, I've got a length of 6 and I've got a length of 4, but the angle enclosed is 32. So this angle is too small. It is not exactly the same shape as these two. So now I can confidently say that this shape and this shape are congruent. They are exactly the same. These two are not congruent. Okay, so let's make our ideas and our proofs of congruency a little bit more mathematical. So first of all, I've just defined the difference between congruent shapes and similar shapes. So in a congruent shape, the shapes are exactly the same. All sides and all angles have to be equal. All corresponding sides and corresponding angles have to be the same. In similar shapes, even though we use the word similar, which can sometimes be a little bit misleading, the angles are equal, but one is an enlargement of the other. So you would usually find with similar shapes that one is bigger than the other, which would make similar shapes not congruent because they are no longer exactly the same. one is bigger than the other. One is an enlargement of the other. In today's lesson, of course, we're dealing with congruent shapes. Okay, so let's have a look at some mathematical ways to prove congruency. So when we're dealing with triangles and we need to prove that they are congruent, we need to identify three properties being the same. You've sort of seen me do that in the previous slides in this video, but now I'm just going to make it a bit more mathematical. So what we could do is look at two triangles and identify all three sides being the same. SSS, side, side, side. If they're all exactly the same in two triangles, we can confidently state that the two shapes are congruent. We also have the proof SAS, which stands for side, angle, side. So again, if you have two triangles which have the same side, and the enclosed angle is the same, so it's in this order, then we can state that they are congruent. We also have ASA, three properties: angle, side, angle. If we have two triangles where we have two angles that are the same and the side in between those two angles is the same, we can confidently state that the shapes are congruent. Our fourth proof is slightly different, and it is RHS, and that stands for right angle, hypotenuse, and side. So if we have two right angle triangles where the right angle is in the same place and the hypotenuse and the side are in the same place, we can again confidently state that the two triangles would be congruent. So we have four mathematical proofs. If we can identify these three properties on two separate triangles, we can go ahead and state that they are congruent. And these abbreviations, what I've highlighted in yellow, is where you would get your method marks when you're stating your justification for shapes being congruent or not. Okay, so now I'm going to talk us through a few quite basic questions, just so we get the idea of how to approach a congruency question and how to go ahead and justify our answer. And then once I've been through a few basic questions, there'll be a few more challenging questions for you to have a go at. Okay, so this is a very typical question. You're given two triangles, two shapes, and you're asked if the triangles are congruent. What you can't do is just say, yes, they are, or no, they're not, because you won't get any marks in a test or an exam. You have to justify your answer. You have to explain your answer. And the way we justify our answer is if we say they are congruent, we have to state one of the four proofs from the previous slide. That would be our justification. If we say no, they are not congruent, then we need to explain why it is not one of the proofs from the previous slide. So I'll work through a few questions so we get an idea of how to approach the question. If I look at these two questions, these two triangles, I can see that we have a length of 6, a length of 3.5, and a length of 4. A length of 6, a length of 3.5, and a length of 4. So quite a straightforward question here. I would state, yes, they are congruent, and my reason, my justification is SSS, side, side, side. Three sides all corresponding. If I was to rotate the shape, like so, now it's a bit more straightforward to see that, yes, indeed, these triangles are congruent. We've got a 6, a 3.5, and a 4, and our justification is SSS. We have a look at another question, same question. Are these triangles congruent? So I look at the triangles, I've got a 4, an angle of 78, and then a length of 3.5. I've got a 4, an angle of 78, and a length of 3.5. So I've got angle, side, angle. here is another question. So the question remains the same. Are these triangles congruent? So if I have a look at these two triangles, I've got a side of 4 centimeters, a side of 3.5 centimeters, and the angle enclosed, the angle in between those two sides, is 78 degrees. 3.5, 4, and the angle inside is 78 degrees. So I'm going to again say yes, these triangles are congruent, and my justification is SAS, side, angle, side. If I rotate this shape around here, again, you can see that the triangles are most definitely congruent. Just make sure that the 78 degrees is in the corresponding place. It is in between the two sides. If this 78 was up here and this one remained down here, that would not prove congruency because the angle has to be enclosed by the two sides. So what we're dealing with here is we're dealing with side, angle, side in that order, side, angle, side in that exact same order as well. Okay, so we'll have a little look at this question here. Are these triangles congruent? So I'm going to look at both the triangles. I've got an angle of 78, an angle of 47, and the side in between those two angles is 4 centimeters. I've got an angle of 47, an angle of 78, and the side in between those two angles is 4 centimeters. So this time I'm going to say yes, they are congruent, and my justification is ASA, angle, side, angle in that order, angle, side, angle in that order. So that is our proof. That is our justification. If I rotate that shape round, we can see that it would be the same shape, or I could even move the shape down here. So now we'd be talking about a translation. I took this shape from here, I moved it so many squares or so many centimeters to the right, and then so many centimeters down. But the main thing is the size of the shape is not changed. So whether it's a rotation or a translation, then as long as the size of the shape does not change, we're dealing with congruent triangles. So if I just go ahead and highlight my justification again, angle, side, angle, in that order, the side has to be in the center of the two angles, angle, side, angle. That is correct. If that 4 centimeters was on either of these other sides, that would not prove congruency. Okay, one more basic example to have a go at before I give you a few questions. If I look at these questions, are these triangles congruent? I have a right angle, I have a hypotenuse, and I have a side of 4. I have a right angle, I have a hypotenuse, and I have a side of 4. So this justification, this reason would be RHS, right angle, hypotenuse, side. And this justification is linked very closely to side, side, side. Because if we think about Pythagoras' theorem, if I wanted to work out that side and that side using a hypotenuse of 5 and a side of 4, a hypotenuse of 5 and a side of 4, then this side and this side would of course be the same as well. So we can take this justification and use it to prove congruency if we have a hypotenuse and one other side that is the same. So again, yes, these two triangles are congruent. I just want to very briefly talk about the abbreviation AAS and the abbreviation AAA and why I haven't included them in this video as proofs. You may watch other tutorials that use AAS as a proof, and that's fine, that is correct. However, for me, if you know two of the angles in a triangle, you're always going to be able to calculate the third angle. So AAS is another way of using the proof ASA, because if we know two angles, we can always work out the third angle. So I'm just going to change that round to read as ASA. Now I think this is a bit more consistent because we're always looking for the side which is enclosed by two angles. We're always looking for the side which is in between two angles. So in other tutorials, you may see the proof AAS applied, and that would be fine, that would be correct. But for consistency in this video, I'm always using ASA. It may mean that you need to work out the third angle, but we're always looking to identify the side within the two angles. You may also be thinking about the abbreviation AAA and why this wouldn't be a proof of congruency. So if I explain it very quickly, if we took an equilateral triangle, which has three angles of 60 degrees, and we enlarged it by scale factor 2, we would end up with one triangle that is double the size of the original triangle. The lengths would be double. However, all three angles in both triangles would still be 60. So when you carry out an enlargement, the lengths of the sides would change. The lengths would get bigger or smaller, but the three angles would remain the same. So AAA is not enough information to prove congruency. So we are not applying this abbreviation in any of our proofs throughout this lesson. Okay, so now it's your turn to have a go at a few questions. What I would like you to do here is I would like you to pause the video, and for each question 1 to 6, I would like you to state yes or no, they are congruent. If you decide they are congruent, I would like a justification using one of the 4 proofs. And if they are not congruent, I would just like a little bit of an explanation as to why you think they are not congruent. Okay, could you pause the video at this point and have a go at the 6 questions on the screen? Okay, welcome back. I'm going to talk through each of the 6 questions individually. Okay, question 1, I would say yes, we do have congruency here, because even though we are dealing with a different orientation of the shape, we have side, angle, side in that order. Side, angle, side in that order. So yes, we are congruent, and our justification SAS. For number 2, again, yes, we have congruency. Right angle, hypotenuse, side. Right angle, hypotenuse, side. Yes, we are congruent. RHS. There's our justification. Number 3, no, we do not have congruency. We've got angle, side, angle. But if I look up here, angle, side, angle. The 6 on this question is not in between the 2 known angles. So this is not enough information to prove congruency. So no, these shapes are not congruent. 4, yes, we have some congruency because of SSS. Side, 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 side. So again, if you can imagine a mirror line down the middle here, this shape is a reflection of this shape, but the sides have not been enlarged, they have not got bigger, they have not got smaller, so we are dealing with the exact same shape. So yes, it is congruent, SSS. Question 5, no, we do not have congruency. If we look at this triangle, we've got side, angle, side, SAS, but when we go to this side, side, angle, side, SA, and there is not the other S to go here. This 6 is not in an appropriate place. The 40 degrees is not enclosed by the 2 lengths of 8 and 6. So no, these 2 triangles are not congruent. Question 6, yes, we have some congruency. Side, angle, side, side, angle, side. In that order, SAS, yes, we have some congruency. Very well done if you got all 6 correct. Remember, your justifications is where you will get the marks and where you will get your method marks in an exam. So please make sure you're not just saying yes or no, you're explaining and justifying your answer. And here's the last questions for you to have a go at. For each question, I'd like you to state whether the triangles are congruent or not. Of course, you need to justify your answer using one of the 4 proofs from today's lesson. If you are stating that the triangles are not congruent, you need to explain why they are not congruent. This little statement, diagrams not drawn to scale, is very common to see in an exam, and that's just reminding you that you can't use a protractor to measure angles, you can't use a ruler to measure sides, you have to be justifying your answer using one of the 4 proofs from today's lesson. Okay, could you pause the video at this point and have a go at each of the 4 questions? Okay, welcome back. I'll talk you through my answers. So for the first question, we have 6, 54 degrees and 5 in that order, side, angle, side. And if we go over here, side, angle, side, with 6, a missing angle and 5, but using our knowledge of angle facts, angles having to add up to 180 degrees, I know that this angle must be 54, so side, angle, side, SAS proves congruency in question 1. Question 2, we have side, angle, side with 48 degrees enclosed by the 2 sides. If we go over here, we have side, angle, side. There is no angle in at this point. The 48 degrees is up here. It is not enclosed by the 2 sides of 6 centimeters. Even if we were to go ahead and work out this angle using angle facts, we would find that it is not 48. So in this question, there is no congruency, and our reason is this 48 degrees is in the wrong place. For question 3, yes, we have congruency. We have right angle, hypotenuse, and a side of 8. And on this triangle, we have right angle, hypotenuse, and a side of 8. The right angle is not shown on this second triangle, but using a bit of knowledge of angles, we can work out by subtracting from 180 the 2 known angles that this is in fact a right angle. So yes, we have congruency using this proof. For the last question, there's a couple of different ways of justifying this. We do have side, angle, side. And then if I look down here, we've got side, angle, side, but there's no angle here. So the 98 degrees is in an incorrect place. Or we could look at it as side, angle, side going the other way, side, angle, side. So here, the 7 centimeters should be in order to prove congruency. So that 7 centimeters should be over here. So one way of explaining it is that this 7 centimeters is on the incorrect side, but we could also justify by saying the 98 degrees, the angle is not in a corresponding place as well. As long as you've came up with some justification as to whether this is what proves that this is not congruent, then that would get you full marks in a test. So we've got yes, congruent, no congruency shown here, yes, congruent, and no congruency shown here. Very well done if you've had a go at all 4 questions and you were able to completely answer those with some good justifications. That is excellent. You've shown a very good understanding of congruent triangles.